discussing about the this is path clear, right? So we are in this first in the definition we have giving the grid and start x and start y and end x and end y. So from the start to the end, coordinators we are giving, and we are checking the anything is obstacle is there or not. If obstacle is there, it will return the path. If obstacle is not there, it will return the screw. So for the obstacles, what we are doing, we are simply checking the one after the other cells by checking if we have said, as we said, it is in two ways. One is horizontal way and two vertical way. Vertical way means when axes are same, the path is vertical, right? So in that case, we'll check from the minimum of y to the maximum of y, okay? And we'll check whether any obstacle is there or not. So here, if grid y and start x. So in the grid, the start x is the x position. Y is the value which we are starting from the start y to the end y. We are checking in the grid. If it is equal to 0, then it is an obstacle. Otherwise, we're saying that we'll continue the loop. If there are no obstacles, then it will go and check the next condition. If it is, the first condition is x's are equal, no x's are equal, not equal, then it will go to the y's are equal. The y's are equal, it will check in the same manner from the minimum of x to the maximum of x. Okay, from that range, it will check whether any obstacle is there by or not by giving the coordinates. Okay, if 0 is there, it will return the false, otherwise it will return the true. So here grid, here it is given. Okay, here grid is given, and we want to check from the 0, 0 position to the 0, 2 position. This path is clear or not? Okay, then from path 0, 0 to 0, 2. Okay, if it is clear, it will display the path 1 is clear. Otherwise, it will display path next we are telling we are giving 0, 0 to 3.0. Okay, from 0, 0 to 0, 0 position to the 3.0 position, we are checking any obstacles are there or not. So in this scenario, it will check, it will give us from so these are the x value and this is y value, this is x value and this is y value. So this is start x and start y. Okay, and this is end x and end y. So in this, it will check and it will find, if it is finding any error, then it will show us path 2 is there is an obstacle. Okay, so if we execute this, it is saying there is no there is first 0, 0 to 0, 2 is having the path clear. Okay, and in the second one is 0, 0 to 3.0. So it is saying there is no false because we have the 0 in between. Okay, 0 in between we have. So that is the reason it is saying. So you can see 3.0 is having the 0. So that is there is no path. So this is 3.0, right? In this 0 is there. So obstacle is there. So it is showing false, obstacle is there. Okay. So here there is no obstacle is there. So it is in this route from 0 to 2, y value 2. Okay, there is no obstacles, all ones are there. So this one and this one and this one. So this is the path, right? From 0, 0 to 0, 2, because here it is calculating from here, this position. 0, 0 is from here. And these are the y values and these are the x value, right? In an index, when we are keeping anything in the grid, this will be the 0, 0 position, right? This will be the 5, 4 This will be the 5-4 position. Last one will be the 5-4 position, right? That is in terms of us, it is 4-3 because index starts from the 5 index as 4. So this is 0-0 position. This is the 4-3, right? So in like that, in the first there is no obstacle is there. All ones are there in this, and when we are comparing this, there is an obstacle, right? So like that, that's the program works. That's how program works. So tomorrow, when in the execution part, again we'll repeat the that execution. If quickly, no one understand. If anyone not understood, or write the mail that I haven't understood some. Okay. So today we'll discuss multi-threading. Afterwards, initially we'll discuss the classes and objects. Then we'll go to the multi-threading concept. So we have in Java, in Python, like Java or C++, we have the classes and objects concept, which starts with the object-oriented programming. So object-oriented programming is a paradigm based on the concept of the objects. Like objects can contain the code and data and code and methods also, and anything in the wood. It refers to the modularity, reusability, maintainability, and real-world mapping of the problem. That is the main advantage of the OOPS concept, right? So a class is a blueprint for the creating the objects. It defines the attributes and behaviors of the object, and we can define it like function we define, and we call it repeatedly, right? But class is again a template, like a blueprint. When we are constructing the building, normally we create the blueprint once, and based on the blueprint, we'll construct real object. Okay, that is a building, right? So the same blueprint can be used many times whenever there is a common structure of structure can be used. Like they're creating the colony of the villas. What we'll do, we'll create a single blueprint, and commonly we'll create any number of villas based on the same blueprint. In the same manner, whenever we want to create different objects, like employee is a class, right? Using that class, we can create objects like many objects, like Mittal as well as Pranav is a object which is created based on the employee class, right? And say 1,000 employees are there, 1,000 trainees are there. The Pranav is a trainee. Now he is going on the training. So we'll create a class based on what is the trainee number, trainee name. Okay, how many training, how many months he is going to take, whether he assessment is done. For that, because of the we'll create a common attribute. Using the common attributes, we'll create a class, and based on that, we'll create the object. Pranav is a object for the trainee class, right? Like that. So a class is a blueprint for creating the objects. It defines the attributes and behavior of any object. Okay. So like here, class robot is a robot class. Okay. So robot is a class which has attributes like name. It has the attribute like the name. So here we are using the init underscore. Underscore init underscore is a constructor. So whenever an object is created, we have to pass this name. Okay. So then based on this name, it will create a object. Whatever pass we pass, based on that, it will create an object and store that. So like here, we are defining a class. In the previous example, we are defining it's a class space robot, right? Here we are defining a class named robot. Okay. So as I said, underscore init is a special method called a constructor. Constructor means whenever we are creating an object, by default, we'll create if we want to create few values over there, then we call it as constructor. So it automatically runs when new object of this class is created. Here, self refers to the current object being created. So when we say self, the name, whatever name value we are sending, that will be stored in the current object. So name is a parameter. So what parameter we pass when making a new robot, and self name creates an attribute variable that belongs to this object. So when we saying self, so this whatever value we are passing, that belongs to this robot class, robot object, current robot object, like that. So how we have created a class. So this is the class, right? So what is the name of it? Robot. And we need to send the some name, like our robot is Sandy, right? So Sandy, that what we need to send. That Sandy will be stored in the variable called name, current, which refers to the current value. So here, while creating an object, how do we create? We have to send a name. We have to use this class name, and we have to give the name also, right? So here you can see robot is the class name, and the value name, here name is there. This Sandy will go to here, and it will be stored in the variable called name. So how do we create an object robot in the parenthesis Sandy? And when we created an object, we need to store somewhere, right? So that we are storing it as robot1. Okay, so if we print robot1 dot name, then it will show us the output as Sandy. Okay, so simply what we have to do, we have to use a class robot and colon. Say as simple as that. So class. Okay, then we have what we have to define. If we have any constructor, we have to define. Okay. Then self what it refers, self says for current object, and whatever we want to pass, maybe a name of the robot. Okay, or this variable we can refer as name of object, name of robot. Okay, then what we are creating, we are creating a definition of constructor, and what we are doing, self dot, you can say simply self dot name is equal to name. In this constructor, we are writing that whatever we are passing here in the name of robot can be stored in the self object. So this is name of robot, right? So this is what we have. This is the definition. This class is having an attribute. Okay, which class is having an attribute which is nothing but the name. We can give the other attributes also. We can create the you can use, we give the functions also, right? So this is while like this a class is created. Okay, then we can print, we can use this to create the objects. Say we can use this to create the objects. How? Robo1, okay, is equal to. So this is a variable where we are storing the our project, right? Then we can print name of the robot. We have done. Here we are passing the robot. So this is again it is throwing the error. One minute, where I did wrong. It says I'm doing many wrongs. So compiler issues I am getting frequently. Just what may be the wrong I have done. 1 minute. Okay, we'll continue the class. At the end, we'll see what is the error out there. Okay. So we can pass maybe the name I haven't given correctly. Self comma name name of the robot. So someone is saying something. Let me check. 1 minute. I'm checking the answers. 2 underscores for init on either side. Okay, two. So I missed 2 underscores. I gave 1 underscore. So thank you for. Okay, so we can print it using the. We can print it using the print of object name dot name, right? What is the? So it is giving the sand, right? Okay, so that's how we can create a class and we can create a constructor. So I thought I have given 2 underscores. I have given 1. Then we can call that object and we can use its object. We can update those objects. Okay, simply to update this object to another, we can simply give robo1 dot name of robot is equal to something else. Okay, so like that we can give. So we'll continue. Thank you for helping me, Mr. Someone. So we have what is an object? So an object is instance of the class. So it represents a specific entity created by the class. So here, say we can create a robot 1 with some other name, robot 2. Then what happens? Another object with another memory location occupying another memory location will be created for this same class. Okay. So attributes or variables inside a class, they represent the state of the object. Okay. So whenever an object is created to represent the state, we can use those attributes like employee salary or employee ID or trainee ID, training period, what is the level he crossed, all those things. So can be represented with the attributes. And methods or function defined inside a class define the behavior of the object. So like, so you want to know the, uh, for a trainee, we want to know registration for a particular training program. So that we can keep as a method in the objects. Okay, so init as we discussed, the init method initializes the object attributes when the object is created, and we can, like robot class with attributes like self name and task, we can create a task also. We can give the multiple attributes also, and we can also give the methods also. We can also use the methods also, right? So here for a robot, the method we are preparing is perform task. So what it is doing? So whenever a task is sent, simply here we wrote to print the task, print that name is performing that task. So here we are using the functions to behave to what that object has to do, or what that object has to get modified or to change the behavior. Say we want to update a trainee to some other level. Then what we have to do? We have to write a method in that class. So here, along with the attributes, we are also writing perform underscore task as a method. Okay, so so that's how we are writing the how do we call in the same like attributes, we'll call that method also. Okay. So robots can be modeled as objects, and we can use anything. So we'll see one more example of this method. Right? Help me if I missed something somewhere. Okay. So if I add some task, okay, so then self dot task is equal to task. Then what we can do, we can write a method. How do we write a method? Definition, method name, parenthesis, colon, and the method we are using, right? So you can see here it is writing definition perform task as self, like that. We can write definition is the keyword for the writing the functions, and this is the function name, and these are the objects or parameters which we are passing. So self contains both name and task also in it, right? That we are sending. This is another method. Init is the one constructor method. This is another method. So here we can directly send this variable, or we can send total object, self object. Self object contains both name of the name of the robot as well as the task. So we are sending the self, okay, colon, and we want to print, okay, the print. If you want to print the name of the name of the this robot, we can simply write self dot name of the robot. Okay, and we can also print. If you want to print task, we'll also print self dot. So how do we call this robot? How do we call this function? As we are calling this here as an attribute, in the same manner, we can also call the function. Okay, robo1. So we have to send two values. So where did I? Okay. Thank you. Yeah. Thank you. So actually, I didn't give the parentheses. So like that, we can call the functions as well as the variables also. Okay. So and the use case in robotics is we can use the object to model some robot. Okay. If you want to perform, if you are creating any, not only robot or any particular task, for that we can create the class in terms of the attributes as well as in terms of the methods also, right? So so this is another example where we are creating an ID, and it is creating the task also, where robot with the ID is executing the task. Like that we are printing for there. Okay. So like that we can prepare for a class, and based on the class we can create a number of objects for that particular class, and we can also update the content, add the attribute, remove the attribute also. Okay. So coming to the inheritance. Then polymorphism. So we have created a class of the robot, a particular robot, but the monitoring robot, the class may be same, but the monitoring robot works in a different way, and surgery robot works in a different way. In this scenario, we have to, based on the signature, based on the signature we are sending, or based on the attributes we are sending, which we should write the different functions in this particular class. That we call it the polymorphism in a classes. And inheritance in the classes. Inherit in the class means one class to acquire the properties of the another. That we call as inheritance of the classes. That means when we are creating a class, we have written some properties of it. When we are creating the subclass, when the subclass is inheriting the parent class properties, it need not to create methods which are used in the parent class. It will be by default can be used. Like here, say this is the parent class, base robot. It is having a definition called start, or a definition or a function called start. So in this start, okay, here this is a base class, this is a parent class, which is common for most of the classes. Then what we'll do when we use this parent or child classes, some features or some attributes or some methods, when they are common, we'll create a common class and we simply use that class in the other classes, right? So that's how that is when we say 10 classes are there, in that a common class is there. Then we create a parent class for that. Common attributes or common methods are there. We create a parent class, and that parent class can be derived in the child classes, which are having specialized properties. So you can see class surgical robot. Here we are sending the base robot. Okay, base robot is the class, right? Base robot is a class, right? Class name that we are sending in the as a signature. Okay, so here we are adding the new method called operate. So base robot is having what it is having? It is having name as well as a start function. When we are sending that to another class, those properties all will be derived to this class. So when we using this class, we can call the previous properties also. Here the operate is the new method which is being called. So, and we are also using the service robot. So you can see surgical robot is one, and which is having the base robot, and service robot is one, which is also having the base robot. But in the surgical, we are calling the function called operate, and in the service robot, we are calling the function called deliver. And we can use those we can use the functions which are in the base class from the derived class. Then another topic is encapsulation. Encapsulation means hiding the details from the end user, like private variables which are defined with the double underscore cannot be seen to the other derived, or if it we can hide those details using the making it private. Okay, like here you can see we are sending a self dot secret is equal to code 123. Okay, so we can make it any hiding, or we can encapsulate the sensitive information so that only authorized methods can access it. The other methods cannot access it. Okay, so again recapping: class is equal to blueprint, object is instance, attributes are the values or the data, and methods are what it has to do. Okay, and using the classes in robotics and healthcare is real world representation and reusability and maintainability and scalability. And classes and objects in Python make it easier to model real world applications in robotics and healthcare. So once again, I'll repeat the main topics which are very important. They are encapsulation, polymorphism, and inheritance. Right? So encapsulation is what we inheritance, right? So inheritance, in this we have created a base class base robot which can be inherited by the two different robots. One is surgical, another one is the delivery robot, service robot. So surgical robot also uses the base robot as a parent. Why? Because this is necessary to it. Instead of again writing 2 times in 2 different classes, we'll write the same class as a parent, and we can use it in any number of specialized cases. So surgical robot is a specialized case, and service robot is a specialized case. So here it is having a special function for it, that is operate, and it is having the special function for it, which is a deliver. So that is what we call it as inheritance. So deriving from the base class, we call it as inheritance. And encapsulation. Encapsulation means hiding the details from the based on the necessity of the users. Say we write we write on the board, right, or a social media blog. So that we want, our intention is everyone can see it. So we are not restricting any user to not to see it. We are writing a notes. That notes can be seen by our friends only. So that is one level of abstraction. And another level of abstraction is writing. You're writing a diary, and that diary can be only seen by you only. That is high level of security and high level of abstraction. So depending upon the user levels of authenticity and authorization, we can hide the details from the end user. For that, we use the encapsulation in the classes. So here you can see we can only this function can use the data. Okay, we can directly without this function we cannot see the data. Then real time. Then we have all those things. So here today we have discussed. So someone asked me one question like tomorrow when we discuss about this what we call multi-threading, then we'll discuss the point you asked. Someone asked me about the multi-threading. Yes, many of you told me I underscore. Okay, obstacle means some Subham Mishra, obstacle means something in the path. Okay, here obstacle is considered as the 0. If there is no obstacle, if the cell is empty, we have considering it as 1 in the grid. Okay, in the previous functions. Okay, okay. Many of Aditi Sen, Himanshu, and Kishan Verma and all suggested me the underscore. So as by mistakenly, I've entered the single underscore because I need to see check all those things. Thank you for helping me. So this public, private, protected, yeah. So that will surely I'll explain while executing the programs in the next class. And that IMPP. So from next time onwards. So Muhammad Asad init. So constructor is something like when it burns, something is born, it should be basically it should do something, right? So that is a default one. Something is burning, but some birth has taken. The new object has to do something with the some function by default. So then you are deleting a file. Then you are creating a file. So you are creating a file. So when you're creating a file, when you're not giving the instructions, by default, it should allocate, say, some 1 KB to the file which is created. So what you're writing the program, how you're writing a program, when a file object is created, by default, it should allocate 1 KB of memory in it. So you will write this by default thing when a new file is created in the constructor. Destructor is when you're destroying an object. What has to be done? That will be written in considered as a destructor, right? When you are destroying a file, right? So where you will be storing? You will be storing either in the bin or completely with 100% you are deleting it, right? So that program you will be writing in the destructor. When an object is deleted, what has to be done? If constructor, normal I am saying constructor is a function which is which specifies what by default has to be done when a new object is created, right? So whenever a new object, a robot is created, by default, we want to give it a name. Without name, it cannot be a robot, or a training as allocation to the any candidate. Whenever a trainee is created, by default, he must have the training ID. Then we'll use that. We'll write a init function where we by default ask for the trainee ID. Right? So anything we want to do compulsory when an object is created, we use the this constructor. Okay. And thank you most